Hi, I am Anta. Today I will tell you about computer vision on NXP board. Of course it's all about NPU, and I will use Debix A as a reference board for this. They kindly sent me the board for this video, so thank them a lot. This video will be pretty long, so pay attention to the time codes at the bottom if you need some specific part, like general opinion, or for example, how to run everything specifically for this board, how to export your network, so on. The first part will be about my opinion, and then I will go more to infrastructure, how to run everything, and some small summary. So let's go. I will start by telling what NXP is. Or is it? When talking about NXP, it's hard to talk only about NXP. NXP doesn't produce its own NPU architecture chip. They just print existing architecture. Usually it's like for NPU, it's Verisilicon or ARM technology. For example, here it's Verisilicon. Moreover, NXP doesn't produce boards suitable for small series. So whatever you test, you will most likely test some boards from partners. Specifically, in our case, the logic will be like Verisilicon NPU that NXP put in the processor, which was put in Debix board. And for example, on my channel, I already tested different NPU from Verisilicon. It was the board on base of Amlogic, and the board was from Hadas. So it's also like a little bit complex. And if you check that video, the difference will be tremendous. It has completely different logic inside. So the main problem with NXP is that developers do not have clear information. There is either too much information or too little. I can tell a little example I already mentioned in a different video on my channel. This spring I was going to embedded world, but no one, and I explore different platforms, and I have few questions about each one of them. And when I talked with NXP partners, no one know how their ML platform worked. Like the general answer was, they have some examples, you can run them. And when I was asking, okay, can I run LLM model? No one knows about this limitation. Maximum they said to me like, go to NXP booth. And NXP booth was the biggest booth on this exhibition. I checked the NXP booth, but they couldn't find anyone who was competent enough to answer me like the basic question about ML. What are the limitations? How can I choose the platform? And at this show, I talked with different vendors of different ML boards like Accelera, STM32, Texas Instruments, Sima AI, MediaTek, and so on, etc., etc. And all of them tell me like basic about their platforms, what are the limitations, how I can run everything, but not the NXP. And suddenly, already after this show, I came across a platform from Debix, and it had reasonable NXP-based board and clear documentation with basic entry points, which hooked me on this video because it was straightforward and pretty clear. I will explain a little bit more my problems with NXP after testing this board, after setting everything up. My general thoughts. there is a lot of documentation. Some of this documentation outdated. A lot of examples are non-usable. For example, here is like examples just on my board. How many of them do you think can support NPU chip fully? And how many of them are fast enough? You will find this answer a little bit later in my video. But there is no information and documentation what you should use first. And like, for example, even Debix, they said, just use TensorFlow Lite. And yes, of course, it's like correct answer in this situation. But NXP doesn't have all this information in their documentation. They just had tremendous amount of videos, like 4 hours of video lectures about computer vision on their platform. They had some random examples in internet with an streamer, for example. I don't know why. And in my opinion, it's like a little bit, they didn't think about like the basic developer, AI developer who want to test all his algorithms on this board. NXP is a great platform. So let's go to the pros. And what is done well. Yes, TF Lite is not fully supported, but it's easier than even Google Corel, in my opinion, which like the native board for TF Lite. This is the first board with visual export tools for networks that I met. I took a couple of network, exported them, and they worked just with visual interface. I didn't expect this. Later in this video, I will tell you how to do this. The chip is good for its like power consumption, reasonable price, and almost everything working out of the box. Even these strange examples with ONNX inference, with TVM inference, they're working. And it's like a little bit unexpected, but it's great. Examples are already on the board. So everything done is good and clear, but there is no like clear vision for someone who want to get in this board. So it's like, and there is no big community around. So it's like think within the think. So let's move to the model export. Have you even before exported to TensorFlow Lite? If yes, then you can handle export to NXP because you already did everything. If you have model in TensorFlow, it's just basic one command, but no one has his model in TensorFlow nowadays, so usually you will have your model in ONNX, and there is pretty regular approach for this export. It's like ONNX to TF Lite library. It doesn't like the best export library, but it's work pretty good. For some of the network, like for example for YOLO V5, maybe YOLO V8, they has their own export. So both of this approach are workable. Specifically for NXP, they did a visual export tool for this process. And they just forked the interface from Neutron and append a few additional buttons in this interface. Wow. And TF Lite is one of the super popular formats, and this export tool is well done, so you can export your models even for different boards through these tools. In my opinion, it's great. Speaking about the export and quantization. Some network, surprisingly for me, exported without any problem. For example, like I tested Dama Yola and it was exported nice. Some regular YOLO worked super nice. For Dyna V2 with this tool, I could export it only without quantization. I didn't find popular LLM models in TF Lite, and there is definitely some problem with their export because like a lot of such models even hard to export in ONNX. Unfortunately, not all converted models can be used. It's similar to what I've seen for some other platforms where sometimes like your expert process is successfully, but when you're trying to run your model, something happens. And in my opinion, most of these problems are solvable, but for example, like I tried to export 5 different versions of ResNet model, and there was different errors for it. But all errors were pretty well documented, and like in general, I understand what I should change in the model to make it run. But I didn't try to do this like deeply, and in my opinion, it's like okay, it doesn't work for me, so I didn't test this model. What are the other important limitation for NXP and specifically for Verisilicon chip? Quantization. This chip is a required quantization. And there are many ways to do this in TF Lite, of course. You can do this with some quantization-aware training, which is popular in TensorFlow if you train your model in TensorFlow. But in my opinion, all this trick, they will require additional time. And if your model doesn't work out of the box, you will have a lot of fun with all this quantization when you want to run this on the board. It's regular question for NPU chip. If you looked my previous videos, it's like pretty common for Google Coral, for Halo. There was a lot of NPU chips where, like even NVIDIA DLA, it's pretty. You should do your quantization for NVIDIA. So, is this chip is worse or better than other NPU chips in terms of experience? I think it's worse than like NVIDIA, Rockchip, and Halo just because of amount of supported network, amount of infrastructure, amount of community, and so on. But overall, it's better than most of the other chips I tested on my channel. And again, everything done pretty well, even errors, they are described pretty nicely. So let's speak about speed. The speed is nice, but far from top devices, of course. About the same as Rockchip 3568, Hades Vim 3 with almost the same architecture. It's pretty similar to Raspberry Pi 5 and CNN inference speed. So it's pretty reasonable for this price. But of course, it's like slower than top end boards like Rockchip 3588, Jetson, Halo, etc., etc. So it's just nice speed for reasonable price, especially in mass production. So if you need your board just to recognize some detection from one or maybe from two cameras, it will be good enough. Speaking of my measurement, here is like some basic networks and basic comparison with them. In my opinion, it's quite nice. Of course, all these tests, they are for NPU for TensorFlow Lite. It's possible to run different frameworks, but I don't want to go deeper in this. So, let's speak a little bit specifically about Debix board. And I like it. It's like, as I first said, they have solved the problem with input points, like where you should start. I must admit that their guide is not perfect. I found few bugs in it, but I could get everything up and running even with it, without big problems. And I need to admit that they have a great support over the Discord. They answered pretty quickly, and they resolve all my questions and issues. I didn't have time to test some of the advices. Maybe in the future I will test them. But the rest of it worked perfectly. So I want to briefly show you how to run the basic example. It should be the same for all NXP board, but of course I will focus on Debix board right here. First of all, you need to install the system, and you have two opportunities. You can use basic Yocto Linux image or Debix OS. And the Debix OS is some Debian fork, as far as I understand. So usually, like at the first thought, for me, Debix OS was preferable. So you need to install system from here. The link in the guide was a little bit outdated. I hope they fixed it. And if you choose Debix OS, you must to install all the necessary packages for Python. I didn't have time to test this because I have this issue that some of packages was missed, and I just switched to Yocto where everything was pre-installed, and for Yocto there was more examples, so I just decided that it was like the same performance test but a little bit less amount of problems. But I'm sure that Debix OS is also usable. For Yocto, you need to go to the folder with examples, and there are two commands here. One is like for C++ example, and the second is one for the Python example. Inside, if you look in the code, there will be like classic Python and TF Lite. So you can run same code for your home PC and same code for this board, which is great in my opinion. Initially, I was a bit afraid of Yocto Linux because I was used to the fact that it's like not fully workable Linux, so it's difficult to install some packages here. But specifically for this version, I installed all that I was needed through the pip. It was nice, everything worked out of the box. So maybe if you need to install some packages from apt-get, they will not work because there is no apt-get command here, but maybe you just can install them directly. I didn't try this, but definitely Yocto Linux should have has some limitation. Also, there are some examples of inference for different platforms on the board. I tried them all. Not all of them work, and those that do work usually was much lower than TF Lite. So I just don't advise you to use them. Also, there is a reasonable question like this board mentions that it has GPU, and maybe you can run your models on GPU, but for specifically for TensorFlow Lite inference, which I tested, CPU inference was a few times faster than GPU inference, and NPU inference was like more than 10 times faster than CPU inference. So there is no reason to run your neural network on CPU or GPU on this board. And speaking of the power consumption, it's minimal and it doesn't get warm. I initially saw that the board had a chip without like some big metal case, and it was look for me like the plain silicon here. And I was thinking, I definitely need some cooling solution for this board, so I asked the guys from Debix for this box. But when I tested everything, the chip maximum temperature when I ran inference here was around 50 degrees Celsius. And with this box, at the maximum, I heat up this case around 35 degrees, which in my opinion, like super nice. It's maybe one of the coolest boards that I tested. So let's move to the conclusions. NXP is probably not the cheapest or the most convenient board. There are many Chinese boards that are cheaper. There are boards where networks expert is better implemented, but NXP is cheap enough for mass production. Like you can find some like boards in the internet, like mass production board. They can cost like 50 USD dollars for such boards in mass production, of course. Uh, if you think that you will produce your device in thousands, the board is pretty competitive in price. What's more important, NXP is like one of the world leader in processors. You won't hit like chip shortage like it was for Raspberry Pi, for Jetson. You won't hit some unpredictable series of cancellation. You will have good technical support. What is more important, this board is completely certified for Europe, America, and for example, it's pretty hard to put some Huawei or ROG chip at hospital because like lack of a lot of certifications of problems, and this board is seem like reasonable for such projects and products. And among boards with such level of supported certification, NXP will be just one of the most reasonable in terms of price. So in my opinion, it's great. Speaking specifically of Debix board, it's a good board for computer vision tasks. In my opinion, for me, it was like more like interesting platform to play with NXP. But I think that like the speed here will be faster than Raspberry Pi 5 for computer vision, and it will not eat a lot of current. It will doesn't warm, so I think it's suitable for some computer vision application. It's like compatible with Raspberry Pi in terms of price. So definitely there are some places where it can be implemented. So thank you for watching. Hope that in the next videos there will be more great boards on my channel. So till the next board, bye.